Taking care of your health is imperative to happy living, and modern electronic gadgets enable easy healthcare. One such device is a fitness tracker. A fitness tracker device offers solutions to individuals towards specific health and fitness goals. Fitness trackers are equipped to monitor your vital parameters, such as heart rate and temperature, amongst others. They can make you accountable for your fitness commitments, help you stay motivated, keep you connected, and track your activity progress and sleep patterns. This video will show you how to create a Bluetooth low-energy-based fitness tracker application on Microchip's 32-bit MCU using MPLAB Harmony version 3. This project is based on the SAM E51, our Cortex-M4-based microcontroller. For this video, we will use the SAM E51 Curiosity Nano evaluation kit. This kit has an onboard debugger. Along with the SAM E51 Nano, we will use the Curiosity Nano baseboard to connect to Microchip's BM71X Pro board, as well as some Micro E clickboards. The Heart Rate 9 click can be used to measure the heart rate, and the E-Ink click bundle is used to display the heart rate. The BM71X Pro contains a Bluetooth low-energy RF module. This BLE module needs to be updated with firmware having compatible private characteristics for heart rate service. The steps to update this is mentioned in the README file provided as part of the demo zip file and will be further discussed later in the video. The project shown in this video is developed using the software tools shown here: MPLAB XIDE, MPLAB XC32C and C++ compiler, and MPLAB Harmony version 3 software framework. Harmony 3 provides peripheral libraries, drivers, system services, middleware, and more. The MPLAB Harmony Configurator, shortly called MHC, is a graphical user tool to configure and generate code for the Harmony libraries. MPLAB Harmony version 3 library code generation is now also supported under Microchip's famous MPLAB Code Configurator tool. You could also use the MCC for generating Harmony library codes. We will be using Harmony packages like CSP, DevPacks, and MHC for this video. The application block diagram is shown here. The Heart Rate 9 clickboard is used to read the heart rate in beats per minute and is interfaced with the SAM E51 using USART. The E-Ink click bundle is used for displaying heart rates and is interfaced with the SAM E51 using SPI. And the BM71 module is used to send the heart rate data over BLE to the Microchip Bluetooth Data Android mobile application. The BM71 is also interfaced with the SAM E51 using USART. Here is how to connect the various hardware kits. Mount the SAM E51 Curiosity Nano evaluation kit on the Curiosity Nano baseboard. Mount the Heart Rate 9 clickboard on the Microbus Connector 3. Mount the E-Ink click bundle on the Microbus Connector 1. And connect the BM71X Pro onto the Extension 1 connector of the Curiosity Nano baseboard. Powering the SAM E51 Curiosity Nano kit is easily done using a USB cable. You can download the firmware project from the link shown here. The BLE Fitness Tracker zip has the demo firmware and you can extract it from there. Open the project in MPLAB XIDE. Go to Tools, Embedded, and open the Harmony Configurator. Here you can open the project graph to see the various SAM E51 peripherals configuration in comparison to the block diagram. The serial communication peripheral, SIRCOM0, is configured as USART to interface with the BM71 module. The system service with timer TC0 is used for the Bluetooth driver to generate a periodic interrupt to advertise and send Bluetooth data. SIRCOM1 is configured as SPI to interface with the E-Ink display. SIRCOM4 is configured as USART to interface with the heart rate sensor click. We also configured SIRCOM5 for debug printing purpose. Using the Harmony configurator, You can easily add other peripherals, reconfigure the project, and generate the code. You can go to the project configuration path anytime and check the various files to understand the implementation of the project. Before you program the code, in MPLAB X IDE under Project Properties, ensure that the SAM E51 Curiosity Nano is selected as a hardware tool to program and debug the application, and then click OK. You can now build your project and program the SAM E51 Curiosity Nano by using MPLAB X IDE. Download the microchip Bluetooth data app file from the link available in the README file and install the app on an Android smartphone. Enable location and storage access from the smartphone settings. On the hardware setup, perform a reset by unplugging and replugging the power cable of the SAM E51 Curiosity Nano. Parallelly, open the microchip Bluetooth data Android app from your smartphone and tap on the Bluetooth Smart icon on the dashboard. If prompted, allow the application to turn on Bluetooth. After power up, the application displays the microchip logo on the e-ink display and initializes the heart rate sensor. After successful initialization of heart rate sensor, the two integrated LEDs on the heart rate 9 click will light up. Now, scan for Bluetooth devices by tapping the Start Scan option on the app. Our demo hardware should appear as MCHP_SAM_E51_HR in the list of Bluetooth devices. Connect to our demo hardware by clicking on it. This will establish a connection between the MPD BLE application and our hardware. Once the hardware is connected, the application shows the different services screen page. Scroll down and tap on the heart rate service. It will redirect to the sensor location page. Place your index finger gently on the heart rate 9 click sensor as shown here. In the bottom right corner of the sensor location page, disable and enable the Notify button. Wait till the LED 0 on the SAM E51 Curiosity Nano board goes off. Once the LED is off, lift your finger. The heart rate value in beats per minute gets displayed on the sensor location page as shown here. Also, the same heart rate value is displayed on the e-ink display. Finally, we have provided some useful reference web links. This page shows the example user guide link for this demo, and the demo source code can be found from the link shown here. We hope you have enjoyed this demonstration. Please feel free to like and share this video, and consider subscribing to our channel to get notified of all the newest content.